Hey there, and welcome to another episode of the Ruby Rogues podcast. This week on our panel, we have Valentino Stoll.
Hey now.
I'm Charles Max Wood from Top End Devs. And this week we have a special guest, and that's Takashi Kokubun.
Hi.
Do you want to remind people who you are? I'm pretty sure we've had you on before, but
Sure.
it's been a little while.
Yeah, I'm kind of known as a template engineer. I'm a maintainer of EOB, and also I'm kind of author the HAML 6. HAML 5 was replaced by another iteration called HAMLIT, so I'm kind of the author of the HAML now. And I also became a maintainer of CMSL this week, so I'm maintaining all those things. And after those kind of template engineers works, I kind of switched the gear towards maintaining a JIT compiler. So Ruby programming, like C Ruby, or also known as MRI, has two different JIT compilers. One is MJIT that was merged to Ruby 2.6, and the other is YJIT that was developed by Shopify and merged to Ruby 3.1. So that has two different JIT compilers, and I've been maintaining MJIT for 5-ish years, and this year I joined Shopify, and I'm currently developing YJIT full-time, so that's basically what I am.
Good deal. I'm frequently surprised at how many companies are running their apps in production without any way of knowing when things go wrong, or who are running them in production and not really having a way of knowing where things are slowing down. That's why I recommend that people use a service like AppSignal. AppSignal plugs into your application seamlessly, whether you're using Rails or Phoenix or something else, and provides you a way of knowing when things go wrong, when things are going slow, and what other problems your application may be facing so that you can fix them and provide a seamless user experience for those who are using your app. So whether you're starting a new app or working on an existing app, you should check out AppSignal and see how it can work for you. Go to appsignal.com. That's appsignal.com. And I think we were planning on talking a bit about the JIT. And just to kind of kick it off, I'm a little curious. So is YJIT going to replace MJIT? Is that the plan?
So currently we are not planning on removing MJIT, but basically for production usages, we do intend to let people use YJIT instead of MJIT on production. We still have MJIT for experimental purposes, because we rewrote the MJIT in Ruby this year. We could possibly explore more aggressive optimizations or optimizations that take a lot of time for compilation, because YJIT compiles everything during the runtime. Unlike MJIT doing the compilation parallelly, it's harder to introduce it takes careful consideration to introduce too complicated optimizations. So it's kind of easy to experiment with complicated optimizations in MJIT first, and then think about how we could adopt that in YJIT. So it's kind of two different ways to experiment with JIT compilers. So I don't think we are going to completely replace MJIT, but still we think that YJIT is for kind of future or longer term JIT goal, I think.
All right, sounds good. So, boy, this goes back. We don't do this as much anymore, but we used to always start with the definition. I think that's a good place to start here. Do you want to just explain what the JIT is, for the normal Ruby person who doesn't ever write JIT in their text editor?
Right. So JIT is an abbreviation of just in time, and just in time meaning we kind of skip the part, the compilation. So JIT is, if you say JIT, it usually means just-in-time compiler. And then by just-in-time compiler, it just means that we are compiling the code on the fly. After you started the interpreter, we start compiling the native code. So if you say JIT, it usually means native code instead of so-called bytecode. Bytecode is something that's executed by the Ruby interpreter usually. If you provide a Ruby program to the interpreter, what it does first is to parse the Ruby program into a syntax tree, and then the syntax tree is compiled into a so-called bytecode that could be kind of easily interpreted by the Ruby interpreter, that is kind of specific to the interpreter and not reusable for any other virtual machine like a Java virtual machine. So the Ruby bytecode is specific to Ruby, but then we could also further optimize that into a native code for example, for Intel and ARM. YJIT supports Intel and ARM architectures for 64 bits machines. And so basically what JIT compiler does is to optimize Ruby-specific virtual machine instructions into native code that's specific to your machine. So you could unblock more optimizations there.
Awesome. So just to kind of break it down for folks and maybe say it in a little bit different way. Yeah, when you run your Ruby program, it basically converts your Ruby code to a syntax tree. The syntax tree then is basically interpreted into bytecode that'll run on the Ruby VM, but the Ruby VM is not as fast as having native code that's compiled to run against your processor architecture. And so the JIT basically then comes in and just in time, or more or less while you're running your code at some point, compiles it down to that so that when you call a specific method or things like that, all of that functionality is already compiled to run optimally on your CPU. And that makes Ruby fast, which makes us all happy.
Yeah, that's our plan.
So you said that you've been maintaining MJIT for the last while, and now you're working on YJIT. Are these you said MJIT's written in Ruby and YJIT's written in Rust?
Yes.
So what's the difference and why the different approach?
So first of all, YJIT has a unique architecture, which was sort of proposed by the lead developer of YJIT, Maxime. So Maxime's PhD thesis was about the compiler design that is called lazy basic block versioning. That is to compile each basic block. Basic block is a simple block broken down whenever you have a branch instruction. Like if you have a if else and, then the block between if and else is a single basic block, and under block between else and end is another basic block. So each basic block is compiled lazily. Like if you reach a basic block boundary, you basically stop compiling it and then just execute the JIT compiled native code. And then when you reach the point that ends the currently compiled JIT code, then you start the JIT compiler again and then compile only that basic block and then go forward. And then if you reach another non-compiled JIT basic block, you compile that again. So that kind of lazy compilation is the design of YJIT, and that requires you to execute the compiler at runtime. Like you are not compiling the code in a different thread. Like MJIT used to be using a native thread that is running parallelly with the main thread of Ruby. So you don't need to worry about the compilation time for MJIT, but for YJIT, because of that kind of assumption, that is actually used by JIT compiler. For example, you can peek into the actual self object or arguments and operand, whatever you want to actually look at. You could do everything at the runtime. So because of that assumption, YJIT is kind of hard to parallelize those compilation process. So you don't want to be slow at compiling the Ruby code in the YJIT compiler. So we thought that, so C language is obviously hard to implement. That's kind of complicated logic. So we wanted to get away from C. However, it needs to be fast so that we don't need to let Ruby slower. So for making Ruby fast, we kind of needed to use a fast language, unfortunately. And then Rust was a kind of a good alternative because that doesn't need GC. Having two different GCs in a single process is kind of like very complicated. So we kind of wanted to avoid that. So it's a pretty good option to make it fast while still allowing the complicated process. So because of the synchronous compilation assumption, YJIT needed to use Rust, but for MJIT, because we were using native threads first of all, and then we also switched the architecture to use a forked child process to do the compilation. Because of that, we needed to kind of give up the Windows support. But now the MJIT compiler is running as a child process of the main Ruby process. You don't need to worry about the speed of the compilation, kind of. So we could just use the Ruby to implement whatever complicated logic we have. So that's the difference between them.
So I'm curious on that, because you seem to make the distinction of MJIT and YJIT there, of one being more thread friendly than the other, right? Makes me think of, okay, well, like the whole JIT purpose is the more you run it, the faster it will get because it caches more of the things and uses the bytecode rather than whatever it's trying to compile each time, right? So how is that kind of like stored and cached at the system level, and how does that interact with the processes for both MJIT and YJIT? That like, is YJIT basically say, hey, if you're doing multi-threaded stuff, we're not going to take advantage across the thread space?
So the thread thing I talked about is more about the compilation process and not about the actual runtime code. The runtime code actually do support the multi-threading. Like the when you run the compiler, it's not kind of multi-threading friendly because you want to actually know about the actual main thread information. Like the as I said, the receiver or arguments. If you run that parallelly, the receiver or the arguments might be changing while you are compiling. So we don't want to use the threading there, but after you compile the code, that's kind of like compatible with the multi-threading. Like for example, if you use Raptors, you could use multiple native threads running concurrently, but that just works. So for the JIT compiled code, so that's not a problem. But it's basically compilation time threading versus the runtime threading, and I think it's not a problem for actual users.
Yeah, I mean, I'm looking forward. I saw your talk just recently on YouTube. Now that Ruby Kaigi has their videos out, and I really liked Ruby 4 was in your title of your talk, which I thought was great. And talking about getting Ruby to be hopefully as fast as Java, right? Well, I think you said 10 times faster is the goal, right? And getting us away from having to worry about all of our data people using Python instead of Ruby, right?
Right.
So, I mean, what is on that trajectory toward that Ruby 4 goal? Because I love just like upgrading my Ruby, and all of a sudden, all my code's running faster. Like, what are some like top things that you see like as making that jump up that path?
So first of all, about the goal I said was not only Java but also like JavaScript. So like Java uses a Java virtual machine, which also allows something like a class loader that is pretty dynamic, similar to Ruby. So if you can optimize Java, which has a class loader or some sort of dynamic things, you should be able to make a similar kind of dynamic language as fast as Java as well. So like if Java can be that fast, Ruby should be able to be that fast as well. And similarly, if you have a V8 or like something as fast as JavaScript, because JavaScript is also a dynamically typed language, Ruby, I think, should be also be able to be as fast as JavaScript, basically. That's the idea. So there's technically no blocker for doing that. We basically want more people to develop that. And fortunately, Shopify provided the funding for developing YJIT with a lot of many people. So like we should be able to do that as long as we continue this effort. And for discussing the actual things that are missing currently, I think we first of all need to be on 100% JIT compiled code on running production applications. So our current actual immediate work is like we have the metrics called ratio in YJIT. That's the ratio showing that how many percentage you are on the JIT code. So like whenever you hit something that JIT compiler cannot handle, you fall back to the interpreter. So that means you need to be slower than the actual, ideally JIT compiled code. And then the percentage is currently like on the benchmark called Rails bench, we are kind of like 89% on the YJIT. I think it's at least better than the 3.1 on the master branch, but we're working hard to make it nearly 100% so that almost everything runs on JIT compiler. So once we do that, we then need to optimize the existing JIT code further. So the first step is to bring us towards 100% ratio in YJIT in the real world applications like Rails, and then optimize the JIT compiled code further. And I think that there are pretty big things that could be optimized in the already JIT compiled code. For example, local variables. Local variables are on the interpreter. We store that on the so-called virtual machine stack. That is not native stack, so it's kind of slower. But we could at least use the native stack, and also we could use registers that are native to the actual machine. So if we leverage or allocate the Ruby's local variables to the registers, we could be more faster, although you always have to think about how we deal with the dynamic things like binding local variables for get could prevent that kind of optimization from happening. But we we have a pretty good way to deal with that kind of optimization. Like we have a way to patch existing JIT compiled code. Like YJIT has a way to dynamically update the existing code, for example, that is used by a so-called like a feature called tracepoint. When tracepoint is enabled, we have to enable the debugger, and we cannot reuse the optimized code anymore. So to enable that, we patch existing JIT compiled code, and that is not easily like achievable in MJIT. That's why I'm kind of favoring in the YJIT currently. So in YJIT, we could do that kind of pretty dynamic optimization, and so we should be able to deal with dynamics like binding the local variables get. So we should be able to do the local register allocation. And the other big thing is method inlining. So whenever you call Ruby method, that takes a lot of cost because in every Ruby method call or block call, you have to maintain a lot of metadata, and that's a lot of an assignment to the registers and like stack. So it incurs a lot of cost. And obviously, Ruby uses a lot of method calls in the program. So once we are able, once we can analyze that each block doesn't need a call frame for that kind of method, or this block doesn't do any inspection on the call frame, then, for example, if you don't use the puts caller or backtrace related information, you don't need to push the call frame necessarily, as long as the method doesn't raise anything either. So for that kind of cases, we can just keep pushing that frame, and skipping that will optimize almost every method call faster. So if every method call becomes faster in Ruby, it means we make it a lot more faster. So by doing so, the performance of Ruby could be much closer to other very optimized languages. So I think that's those two things are kind of like the major thing that will be brought to Ruby 3.3. The currently developed version is 3.2. We are trying to make it stable by the end of this year. So we are not going to introduce those two optimizations this year, but for the next version, we were planning on doing those two big optimizations.
Yeah, I did see at 3.2, you mentioned you have the bytecode monkey patching, which lets you to make your own JIT on top of the JIT,
yeah.
which is kind of funny. So how do you keep track of your optimization progress? What kind of monitoring do you do while you're running stuff and testing specific things? Yep. Do you have special tools or visualizer? I'm just imagining a dashboard for instruction sequences just running, right?
Right. So we do have some tools to monitor that. First of all, we have a benchmark harness called YJIT Bench. It's a GitHub /Shopify /YJIT Bench. And we have a bunch of real-world benchmarks, such as, first of all, Rails Bench. And another thing is recently added with Ruby LSP. So we develop a language server developed by Shopify, and we added the benchmark harness that's measuring the performance of the Ruby LSP. So if you make it faster, that your local development experience becomes faster, because we also enabled YJIT by the Ruby LSP language server. So those kind of real-world applications are kind of compiled into a open source benchmark there. And so we want to, we can easily measure the metrics using that benchmark harness. And we have a metrics generation system inside YJIT that is called YJIT Stats. So if you pass, or first of all, you have to enable the stats when building a Ruby interpreter. And then once you build that, you can pass --YJIT-stats to enable stats. And when you pass that flag, you can either instrument the stats by calling a method to return a hash that includes the statistics, or at the end of the interpreter stop, you see the every metrics at the end of the interpreter exits. So if you run the YJIT bench with --YJIT stats, you can see the metrics at the end of the program. And then you could also see that the overtime change through the method call of the YJIT stats method call. So the two things we are currently doing is, first of all, we run YJIT bench on Rails bench on every single Ruby commit on the GitHub Ruby repository. And so whenever we merge something, we can easily check what is changing in the Rails bench. For example, we often monitor the change of the ratio in YJIT for Rails bench, so that at least we don't become slower than the previous revision, at least on the Rails bench. And we also have like website called speed.yjit.org. That is to monitor the visualized graph of every YJIT bench, including Rails bench. So if you open the speed.yjit.org, you can see the graph or historical changes over those benchmarks. And finally, we also have internal deployment of YJIT. So we have two different monolith, or we have a monolith and also a pretty big, highly optimized usage of the Ruby application. So for that application, we deploy YJIT on production in a so-called canary cluster. So there's a small cluster that deploys YJIT, and we can monitor those metrics there. So not just the pseudo Rails application that is called Rails Bench, but also we monitor the actual performance on production as well. So that way we can kind of track not only easily monitorable metrics, but also the actual metrics on our business related applications.
That's really cool. So can other businesses contribute to these kind of canary stats?
Currently, we don't provide a way to make it visualized in the dashboard, but maybe what you could do might be, if you have something intensive in your application, and if it happens to be open source, you could probably contribute that kind of code to YJIT Bench. And so if you do that, we can easily learn that. If it's just proprietary application code, even if we can see the graph, there's no way to debug that in depth. And so we cannot help you anyway. So just having a graph is sometimes not helpful. We should definitely be able to see the code. So if you can carve out your workload into a YJIT Bench, that would be really cool.
Yeah, that'd be awesome.
Yeah.
I would love to see kind of how other companies are taking advantage of the JIT and how they progress, right? I mean, Shopify's big enough that it could get a lot of feedback from their services, I imagine.
Yeah. Speaking of that, because you're talking about measuring benchmarks and stuff like that. One thing that I'm curious about is that, is there beyond sort of monitoring and seeing what's going on with the JIT? Yeah. Is there some practical thing that I can do on my apps if I have a performance concern somewhere that, I can say, okay, JIT it to death?
So I think if you if it's hard to carve out your workload into YJIT Bench, what you could do is about YJIT stats. So if you build your maybe we should actually make it easier to build the interpreter with stats enabled, but there's a way to enable YJIT stats. And then if you build Ruby that way, you could run your application with YJIT stats enabled and then see how the stats are looking like. And then if you can just provide the YJIT stats to us, and then we could see what kind of things are fading or at least exit into the interpreter. So for the first milestone, we want to make the ratio in YJIT 100%. And then if you just provide the YJIT stats, we could at least see why the ratio in YJIT could be low in your application. So we are kind of prioritizing the our JIT compilation development process by looking at those stats. So if you have the stats that look different from our stats, then providing that could be allowing us to prioritize optimizing your workload. So that might be a good first step, I guess.
Yeah, I saw Shopify, somebody pointed me to Shopify's boot program where you could dual boot Rails and dual boot even Ruby versions. I kind of want to test out some of this JIT stuff on it and see. I don't know if it allows doing that or if it's just versioned or. Yeah, I think having that ability to see even just what your CI does, it would be nice to have something I could just snap in. Is that something YJIT Bench can kind of do for somebody? Could you hook into YJIT Bench in a CI against a specific portion of your Ruby?
If you are if you want to run your local code without publishing your code into the internet, maybe you could use a so-called harness in the YJIT Bench to hook your application specific logic to the YJIT Bench. If you want to see the comparison between non-YJIT version versus YJIT version, then you could definitely plug that into the YJIT Bench locally and then without publishing that to the internet. And when you do that, because we already have a Rails bench, maybe you could use some of the code to call the Rails application code. If you're interested in plugging your Rails application into YJIT Bench, then you can definitely look at Rails bench as an example to call the Rails endpoint, and then you could measure what the stats look like there, and also compare between JIT enabled and JIT disabled version, I think.
Hey there, this is Charles Maxwood. I'm excited because I wanted to let you know about this thing that I pulled together that I've been dying to have this for years, and I never felt like I could. And then I just realized that there's no reason why I can't. So I'm putting together a book club, and we're going to read development-focused books, career books, technical books, whatever. The first book that we're going to do is going to be Clean Architecture by Uncle Bob Martin. If you're not familiar with Clean Code or some of the other stuff that Bob has done, check that out. I've also talked to him on the Clean Coders podcast, which is on Top End Devs. But we're going to get on. He's going to show up to some of our meetings. And what I'm thinking is we'll probably have like 5 or 6 people part of the conversation along with Bob and I at the same time. And we'll just, so somebody can come on, they can ask their question, and then we'll just rotate people through. So we'll mute one person, unmute another person when it's their turn to come on and be part of the discussion. So we'll do that for like an hour and a half. And then the other part of it that I'm putting together is just kind of a meet and greet gather area on GatherTown. And so after the meetup and the call, what we'll do is we'll all go over to GatherTown, and you can just log in, walk up to a group and have a conversation. And that way we can all kind of get to know each other and make friends and get to know people across the world. One thing that I'm finding is that, the meetups are starting to come back, but a lot of people don't have the opportunity to go to a meetup. And I really want to meet you guys and talk to you. So we're going to put all that together. It'll all be part of that book club. You can go to topenddevs.com/book club to be part of it. And I'm looking forward to seeing you there. The first book club meeting will be in December, the beginning of December. We're starting the first week of December. And you'll also be part of the conversation about which book we do next. I have one in mind, but I want to see where everybody's at. So there you go.
So how do you feel about Rust?
All right. So
there we go.
I started using that in my private project before joining Shopify, and then I'm now like almost full time writing Rust. And first impression was like it's too hard to write, basically. So like Ruby is pretty easy to get in, but like Rust is too hard to like start writing, because you need to fix every single compilation failure, and like it's a lot of failures if you start writing that. And the largest difference to me was the move semantics. So like if you have a variable or like a reference to something, you cannot share that between different like places. If you reference that variable, it basically is gone to that function, and then you cannot use that variable anymore unless you are doing like intentionally explicitly sharing that as a reference. So that kind of semantics is like hard to understand unless you have experience in C++ that also has some sort of like move semantics partially. So Rust is pretty well designed language in a way that that allows you to have no GC. And so it feels to me like Rust allows you to solve too complicated problems, and like that is exposing the problems to users instead of hiding that by having a complicated logics like garbage collection. So like if the programming language itself has a garbage collection, you don't need to solve every single programming hard problems. But Rust allows you to solve it by thinking about essential problems. And so it's kind of like a trade-off. Like if you are interested in writing a fast code, maybe modern options are basically Go or Rust or Zig. But if you choose Rust, it's harder to write compared to at least Go. But it's like you can, if you want to enjoy solving difficult problems, then you might as well like try Rust for doing that. So at least it's an interesting problem, but like experience. But if you are just want to get things done, Rust might not be an option for you, I guess.
So I'm curious how your experience has been like tying back into the C code portion of Ruby. Is that experience pretty smooth with Rust? Like I imagine at this point, YJIT has a substantial, framework in place to hook into. Is that smoothing out, or is it getting more complicated over time?
So this is kind of also another major like challenge in using Rust. So like Rust is not like kind of hard to integrate that with C basically. So whenever user need to integrate a C code, you at least need to declare unsafe. So if you integrate your Rust code with C, you basically have to like say unsafe block every single time. And at least it's hard, and like So there's a language called Zig, and that's also a kind of a modern language. And Zig is designed to be easily integratable with C. So if you use that language, you don't need to do a lot of things for encoding the C code directly. But in Rust, you at least have to generate a binding similar to what you are doing in Ruby. So like you first of all call the bindgen tool to use LLVM to pass C code and then convert that to Rust declaration. And then you can link the C code and Rust code together. But again, you need to use the unsafe block. And also you have to do the type conversion between C types and Rust types. So like it's I would say it's almost as hard as using C from Ruby. So it wasn't like a good experience. And like we at least already have an interface for calling major C Ruby C functions already. So it's not getting worse over time, but still we sometimes have to add another declaration of C functions to the YJIT. So it's not easy, but like it's not too difficult either.
So what kinds of optimizations are you putting in now? And I guess what does Rust offer in that way? I'm just curious, instead of writing it in C or Ruby like the other JIT is.
So I think we are not really leveraging Rust optimization, but like we are sort of assuming that Rust is fast enough. At least because we don't have a garbage collection. Whenever I write Rust, I kind of assume that every single like struct is allocated on stack, so that we don't need to use a heap for heap management that is slower than stack allocation. So like because we have memory semantics, I think we are transparently always leveraging the stack allocation optimization, which is at least not possible in Ruby, or like, it's not possible, almost always not possible in Ruby. So yeah, we are kind of leveraging that, but basically we assume that Rust is fast whenever we write that.
And what's coming? I mean, what kinds of things do you look at now? Because it sounds like your JIT implementation is relatively stable and mature. So yeah.
So for YJIT, the recent work that I've been doing was CodeGC. So in the Ruby 3.1, the first release of YJIT in Ruby was basically like if you start Ruby interpreter, it allocates the physical memory of 256 megabytes at once, and then use the code, like start writing the code blocks to the pre-allocated block of the memory. However, obviously it consumes a lot of memory even if it's not needed for the process. So we changed the architecture this year to lazily allocate the memory pages one by one. So if you start the interpreter, it doesn't allocate a lot of like physical memory. It just allocates a virtual memory, which is not actually consume the physical memory. So we allocate virtual memory and then use the physical memory over time. It's an improvement in 3.2. However, we still need to leave code used by initialization without garbage collection. So like, for example, if you have a Rails application, you do a lot of initialization process in the Rails initializer, for example, and then you will not use that code anymore after the initialization finishes. So it still like wastes some memory usages without garbage collection. So we introduced CodeGC, so like a feature to garbage collect your JIT code as well. And that's I've been a primary developer of CodeGC so far, and then we first of all needed to change the layout of the code or the order the code put in so that could be easily garbage collected. And then we also implemented the algorithm to garbage collect everything in the JIT code. And so what it does is you have an option called YJIT exec mem size, which is 256 megabytes by default. And then if the memory usage hits that limit, we start the CodeGC, and then it basically frees every single code, including on-stack one. So like on-stack means if you are calling something in the caller, then it's on stack. And so we cannot free that immediately, but we can at least invalidate the code so that when you leave that stack and then come back again, you can recompile that. So by freeing every single code in that 256 megabytes, you can start recompiling only what's needed after the CodeGC is triggered, so that you have more compact code and you have no initialization code if the CodeGC happens after initialization. That way, you save more memory, and as well as having more localized code that is faster than less localized code. So that's the kind of optimization I've been recently working on.
Cool. So is this what you're doing full time? You said at
Yes,
Shopify?
right. So I'm hired as a YJIT team member, and so even while I'm also a maintainer of MJIT, I don't really work on MJIT at work. However,
Mm-hmm.
sometimes other folks are working on something else, such as object shapes. So object shapes is a recently merged idea to CRB that is to optimize instance variable access, basically. So for implementing that, they needed to fix some code in YJIT and also MJIT as well. And fortunately, now Shopify has a MJIT maintainer, so they could talk to me and do some pair programming to fix in something in MJIT when needed. So I've been sometimes helping other developers change MJIT, but for developing MJIT, there's rarely necessity of changing MJIT, so I didn't need to MJIT for my own work. So that's our work, my work at Shopify.
So I'm curious about the object shapes and what ended up needing to get corrected in JIT or YJIT and MJIT to accommodate object shapes.
So object shapes is an idea to sort of compact or compress the information of every object into a single 64-bit value. And so let's say there's an object that has an instance variable named A and instance variable named B, and also it's frozen, then that kind of information could be compressed into a 64-bit value. And so if you can do that, JIT compiler can only check those 64 bits by a single instruction. So that's faster than checking, for example, this object has an instance variable named A and this is frozen, then you cannot set the instance variable because it's frozen. So that kind of check needs to happen by multiple instructions in the previous implementation, both for YJIT and MJIT. And because of that, because we want to leverage the new architecture or the object shape, because the purpose of object shape is to optimize instance variable access, and also because we wanted to not complicate the implementation, we basically replace the previous implementation with the new implementation. So you are kind of forced to use the new optimized code in both MJIT and YJIT. So as long as you are removing the old implementation, you have to support object shapes based access in the MJIT and YJIT. So that's why it was needed to be modified.
So is it faster still to freeze everything?
Well, that check is freezing.
That's a joke.
Yeah. Right. I mean, so when you do when you freeze objects, that now it transitions the concept of object shapes into a frozen object shape. So it's not optimized, but at least for accessing the frozen object, that's supposed to be a little bit faster. So that's current status.
Well, that's good to know.
Yeah.
So I'm seeing here Ruby 3 has ARM support.
Yep.
Have you run benchmarks to see if M1 actually does perform better with that adaptation?
Right. So
And tell me, I'm curious, that seems like a huge challenge to change, adopt another architecture. What is that process too?
Right. So our initial implementation that was released in Ruby 3.1 was only supporting Intel. So whenever you see Ruby's virtual machine instructions, you can just compile that convert that directly to Intel instructions. So that was the previous implementation. However, you now need to switch that to Intel and ARM. So you need to basically have an indirection between Ruby virtual machine and the native code. So we introduced the so-called IR, internal representation, intermediate representation. So there's a so-called YJIT IR in between those two things. And we kind of first of all, we introduced that layer, and then we added a backend, like Intel backend and ARM backend. So if you, instead of directly generating the Intel code, but doing the generating the IR, you can automatically support Intel and ARM by using that. So the process was we first implemented the IR and also two backends to that, and then we gradually replaced the Intel-based generation to IR-based generation, and then we did that for each Ruby instruction one by one. So by completing that, we then supported the ARM for every single instruction in the interpreter. So that's how it worked, and I think it took a half year this year. So early this year we worked on rewriting YJIT into Rust in like everywhere, and then we've now started working on IR. And so I think overall I think it took almost a half year, and so it was a long process. And then I think the hardest part in doing that was the difference between Intel and ARM. So when you write native code in Intel, that will take care of the so-called instruction cache. So like if you have a native code in memory, it's cached by CPU, and so Intel CPU will take care of invalidating the cache so that when the code is updated, it will run the new code after that. So that's easy for Intel, but for ARM, CPU will not take care of that, and so you basically have to compiler needs to take care of what kind of code needs to be flashed from the cache of the CPU. So ARM needed to have a special support for flashing the code that we've written immediately. So because of that, because we didn't need to do that in Intel and we newly needed to do that, we had a lot of segmentation faults in the ARM part. By just converting the Intel to ARM, you don't introduce the inversion process. So whenever we do that, we sometimes see the segmentation fault because of that kind of thing. And we've even worked on that this week as well, even while the ARM support was months before at this point. So yeah, it's been hard for supporting ARM. And then once we did that, I think the performance improvement was good. On Rails bench on M1, I think that was 30% better. You can also see the ARM's performance benchmark on speed.yjit.org today, thanks to Noah developing the ARM support on the YJIT website. And so, yeah, I think even for real applications like Rails, you could see some 10% or 30%-ish range of performance improvement using the ARM architecture. So it's not worse compared to Intel. You can get fair bit of optimization in both Intel and ARM, which is good. But one interesting thing was that if you run Intel code on Rosetta on M1, you could also kind of JIT the execution. YJIT generates Intel code, and then Rosetta will convert that to ARM. And surprisingly, it kind of ended up being faster than our ARM generated code. So it was kind of unfortunate, but I think Rosetta will not be maintained for a long time. So I still needed to support ARM. So yeah, that's interesting experience.
That's really funny. So I'm curious, are there architectural frameworks or hooks that can be taken advantage of for each individual architecture with Ruby? Are there optimizations that can be pursued for each architecture? And are there strategies for reaching for those?
So because we have a YJIT IR to support those architectures, we have a separate backends to each of the IR introduced by YJIT. And so the way we do optimization, architecture-specific optimization, is to basically split everything after IR for each architecture. So we have a so-called concepts called passes. You generate IR first by the YJIT compiler, and then IR go through a concepts of the passes, and then when you go through the passes, that will be generating more optimized IR. So you have a register passes for register allocation. So if you go through the register allocation pass, the IR will, instead of using the memory every time, that will use register. So it's faster. So by transforming the IR through the YJIT passes, you can perform architecture-specific optimizations because, for example, register allocation is also architecture-specific because the number of registers is also different. So by doing so, we allow architecture-specific optimizations such as choosing more optimized instructions for the different cases. ARM has for newer machines, we have single instructions for doing atomic operations. So we could do that kind of thing by splitting the backend for different architectures over the YJIT IR.
That's really cool.
I'm kind of curious if somebody's listening to this and it sounds interesting to them, not from the standpoint of, oh, this is what it's doing for my Ruby code, or this is how I take advantage of the YJIT, but more along the lines of, I'd like to contribute to this, or I'd like to understand it better, right? Because we can only talk about it for so long, and then we all have to go back to life. And so, if somebody wants to dig deeper or contribute, What resources are out there for that?
So we have documents for contributions, such as we have now on the ruby.git repository, we have a directory called doc. And then under doc, we also have a YJIT directory. And under YJIT directory, we have YJIT.md and YJIT So those two things can be referred to for using YJIT and also contributing to YJIT. And that has a section called YJIT hacking. And then you could use that as a starter to learn about the YJIT journals if you are interested. And also for YJIT, we have a lot of external contributors actually. So you may look at what other people are doing there. And also you could maybe try doing something similar to those external contributors. Like we have some forks from GitHub that are contributing to YJIT as well. And so, as I said before, we have YJIT metrics, YJIT stats generated by the --YJIT stats flag. And it's kind of easy to improve the metrics when it's not reaching 100%. Like that will show, either show the reason why it is not 100%, or it will show that we are not collecting the metrics correctly. So if it's not 100%, then you can at least add the metrics, or if it's already added, then you can fix the metrics by looking at the particular place that is incrementing the counter. So I think that's a great way to do the contribution, or get familiar with the YJIT.
Awesome. You have anything else to ask Valentino? I think I'm tapped out.
I'm curious about the HAML updates.
Oh, yeah.
I mean, what is it? 1.7 times faster than the last implementation, the last version. It's now faster. I mean, Slim is the slowest template engine, which is kind of funny because it's one of the more popular ones for the syntax. So what was done to make that huge perf bump?
So first of all,
they put it through the YJIT.
I haven't tried enabling YJIT, but that's because we have ERB benchmarks. So YJIT bench, I think it should be also make it faster as good as ERB. So it should make it faster, but for developing HAML, I often don't use YJIT, so I'm not sure about that yet. So, but still, without YJIT, HAML becomes 1.7 times faster than HAML 5 in HAML 6. So yeah, it's a kind of major improvement. But the moment when I started working on HAML was the HAML 4, and that was HAML was 7 times slower than Slim, basically. So it means that from HAML 4, HAML 6 is 7 times faster today. So yeah, that's a huge improvement. And the reason why we weren't able to reach the performance of Slim for a while is that HAML has two different blockers for doing that. One is HAML helper. So unlike Slim, HAML provides some helpers that can be used inside templates, like HAML tag and capture. And capture is a pretty complicated mechanism that allows users to do whatever they want. So making the HAML as fast as Slim requires dealing with that kind of mechanism, or just throwing away the slow design. So I was kind of doing the optimization that are possible without fixing or breaking the compatibility in HAML 5. HAML 5 became 4 times or 5 times faster than HAML 4 without breaking compatibility a lot. So that was made without breaking everything. However, I had the idea of making faster without breaking the compatibility, but still dealing with the hack or removing the complicated mechanism for cases that are possible. But the problem is it's pretty hard to implement that kind of complicated process. So I was not doing that because it takes a lot of time to do that. But then the founder of HAML called Hampton reached out to me saying, you can just remove that. So we ended up removing the features that are blocking HAML to be faster. So now we don't have capture helper, unfortunately. And we don't need to deal with that kind of complexity. So you don't have features that Slim doesn't have, which is why it's now as fast as Slim, basically. So now HAML 6 doesn't have some features, but still it's as fast as Slim today.
Nice.
That's really funny. Just remove, for everybody out there, just remove things that are blocking you, and suddenly everything is faster.
Yeah. All your slow code. I'm going to do that with all of my code. This is slow. Out. So this is slow too. I don't need it either.
Right.
So I'm curious at Shopify, they primarily lean on ERB.
Yeah, I think so. Yeah. The Shopify is using ERB mainly, and also for users, the CEO Toby authored another template called Liquid template. So like users are using Liquid templates, but for our own implementations, I think we are using ERB. So my contribution is basically not utilized there, but it's good.
So what got you? I know you're the author of Hamlet, which was like kind of the jump to make HAML faster from the beginning. What got you into that? Being like, oh, I should make this faster.
So as of the HAML 4, I was kind of a university students at the time, and then I was into compiler stuff. Like I was writing C compiler and the schema interpreter, and also like generally I was into compiling something. And then HAML was the template language that the previous employee, the previous where I was a student there was using. So like I was in Cookpad at the time, and Cookpad is using HAML everywhere. So like if I were to work on template language, then HAML should be the go-to for making the impact at the company. So I started writing that. And it was funny enough, like there was another person doing that at the time. So he was writing another implementation of HAML called Fast HAML. That was later renamed to FAML, but so we ended up having two different faster HAML implementations at the time, and we were kind of competing with each other. And how it went was I skipped implementing some feature that HAML did have, and so because of that, Hamlet ended up being faster than Fast HAML because Hamlet was basically broken at the time, and so HAML became the fastest implementation because I forgot to implement something. And then I thought about the other author said, oh, Hamlet is fast because it's broken. And so I was kind of worried about that. But then I figured out we could change the design a little bit to reasonably allow that kind of optimization. And then we incorporated that incompatibility in HAML 6 finally. So that's how it happened. Hamlet became faster because it's forgotten. We ended up using that in the HAML 6 as well today. So that's the story.
You have a history here of just making everything run faster as upgrades, That's all. I'm a longtime HAML user. I prefer it over Slim. I know a lot of people really love Slim, but
yeah, now I'm also maintaining that. So
the issue that I run into, and the reason that I like HAML, is that I am not a designer at all. And so I can play with spacing and stuff a little bit, maybe you switch a color here or there, stuff like that. But making something look the way that it ought to look, making it easy, making it flow, it's just not really my thing. And so what I wind up doing is I wind up going to themeforest.net and buying templates, HTML templates, right? So the first step is you put your HTML in a view, and then you put all of your assets in public, right? And then you can eventually move them into some kind of asset manager, but Webpacker or whatever. But you don't even have to do that. And sometimes I just leave it, and then I just have a CSS file that I just load in after everything else and say, this is me clobbering anyway. But what's frustrating is a lot of these layouts, it's like this div hell. and it's fine. It's fine. You have that slant going in, right, for all of your different components.
Right.
And yeah, eventually those will all move into web components or things like that, or partials. I don't use partials anymore. I just use web components. Anyway, but the issue I run into is finding those stupid close tags. It's such a mess. And then the other thing is they use Bootstrap or something for the basis of it. And so it's got 18 classes in it. And I'm trying to figure out, okay, this div has, 18 classes, and, where does that actually, open and close? Because with HAML, it's easy, right? Because it's just indented. Then so that for me, more than anything else, it's that frustration of, okay, where do I find the close tag on this? And I'll edit something and I'll delete a close tag or add an extra close tag, and then everything shifts, right? It is anyway. So yeah, so thank you for making that fast. That makes my life better.
Sure.
It's funny because that kind of reminds me of Python, the arguments where people, that come from Python doing Ruby, and they have to add the end to the definition. Yeah. and they expect everything to be neatly, neatly indented.
Yeah. Of course, I'm a jerk, and I just want to then screw with my indentation on purpose. But I have a I have a plugin for Rufo on most of my Rails apps, and so I save the Ruby file and it auto indents everything and cleans up all the stuff.
I'm curious, is there any optimizations you've taken out of HAML that you can apply to ERB, or are the designs kind of just two completely separate?
So what I've been kind of thinking about was to sort of some helpers. So like HAML is now using the template engine framework called Tempo. I'm also like a member of Tempo as well, and like also became a gem owner recently, so I can just reset. But basically, what it does is similar to YJIT, kind of. So like there's some concept called tempo IR, like similar to YJIT IR, and then similar to passes, we have filters. So like if you like IR goes through filters, the IR becomes more optimized. So as long as your template engine uses like a tempo IR, you could optimize that similar to HAML or Slim by using the filters. So we have ERB implementation using tempo IR inside tempo gem, and so we could just insert IR filters used by Hamlet and HAML to optimize the ERB further. I think we could also use that in Slim as well for some cases, although for major benchmarks that might not be impacted by that, but still you should be able to share some of the optimizations. For example, when I was writing Hamlet, I wrote some filter to split the string interpolation into the segments so that you could concatenate that with the surrounding strings by compile time instead of doing that on runtime. So by doing so, the string concatenation becomes faster, and obviously that could be used for other template engine as well. And so currently the ERB implementation inside the Tempo gem is slow, but we could improve that if we want. But basically, the ERB implementation used by Wales or other places is usually a gem called LB, and it's not using Tempo. So it's kind of hard to leverage the capability there. But if we want to compete with that, we could implement everything in the Tempo as well, and then sort of replace LB in the future. But that's the current situation.
Awesome. So is it as fast as ERB then, or does it matter? Because I always ask the one, and then I'm like, is it fast enough? And it seems like it's fast enough. But yeah, is it as fast as ERB?
So yeah, I think we could also do some optimization, such as removing local variable in the indirection inside HAML or Slim as well. So like ERB sometimes becomes faster than HAML in some cases, but generally for most cases, there's almost no meaningful difference between those template engines at this point. So you shouldn't need to worry about that if everything is as fast as those things. And so it's a pretty minor problem. We could make it even faster, but still it's like a 0.1 or like a 2% ish changes at this point. So you don't need to worry about that. Like HAML, ERB, Slim are fast enough, I would say.
Yep.
So how are your studies going? How do you juggle all this?
I know you maintain half of Ruby at this point, right?
Right. So that's kind of part of the reason why I joined Shopify. So like prior to joining Shopify, I was doing the proprietary distributed system maintenance and the previous employer. So like the open source maintenance was only possible after work time. And then I got a child 2 years ago. So like I needed to spend more time taking care of the child. So like maintaining the open source requires a lot of time, but still I don't have time for doing that. So by making the full-time job open source maintenance, I was now able to spend more time in open source. That's one way to approach it. And I guess the other approach is to sort of switching the projects over time. Like HAML doesn't really need a lot of time for like all the time. Like you only need to do something when releases or changes or other like dependency update happens. We do need to do something, but basically the way it works is I work on HAML sometimes and then leave that and then go to another project, do something, because during that period, HAML doesn't need any help from me. So I kind of work on a lot of things, but in a different moments, basically.
Cool.
How is your child? Have you found yourself trying to optimize fatherhood as you go along?
Well, yeah, like
is that KJIT, like KidJIT?
Yeah. I'm optimizing myself for like dealing with that kind of problem. But like she's now 2 years old, so it's getting easier and easier over time. And now I can just happily play with the kid when I'm not working, and then I can also like go to the park together and like spend happy time compared to the early days where the kid was basically crying all the time. So now it's optimizing both sides. Like the kid is kind of optimized towards playing with me myself, and also I'm also optimized towards taking care of her better. So that's better now.
That's great.
Yeah, at 2, if you leave food out, they won't starve. So, all right. Well, yeah, we're kind of getting to that point. I have a hard stop in about 18 minutes, so I'm going to push us toward picks. But before we do that, if people want to follow any progress or see what you're working on online, where do they go?
I am available on Twitter as a Kokubun, or becomes a 0, and then I'm also available on GitHub as well, on the same username. So I think those are good resources. Like I basically announced the major open source work on Twitter, and also you could see everything on GitHub. So those two I would recommend to people.
Awesome. Have you ever wished that you had a group of people that were just as passionate about writing code as you are? I know I did. I did that for most of my career. I'd go to the meetups. I try and create other opportunities, and it was just really hard, right? The meetups, I got some of that, but they were only like once or twice a month, and it was just really hard to find that group of people that I connected with and really wanted to, talk about code a lot, right? I mean, I love writing code. I think it's the best. And so I've decided to create this community and create it a worldwide community that we can all jump in and do it. So we're going to have 2 workshops every week. One of those or 2 of those every month are going to be Q&A calls, right? Where you can get on, you can ask me or me and another expert questions. The rest of them are going to be focused on different aspects of career or programming or things like that, right? So it'll go anywhere from like deployments and containers all the way up to managing your 401k and negotiating your benefits package. We'll cover all of it, okay? And then we're also going to have meetups every month for your particular technology area. So we have shows about JavaScript, React, Angular, Vue, and so on. We're going to have meetups for all of those things. I'm going to revive the freelancer show. We'll have one about that, right? So you can get started freelancing or continue freelancing if that's where you're at. And I'm working on finding authors who can actually do weekly video tutorials on something for 10 minutes that's related to, again, to those technology areas so that you can stay current, keep growing. So if you're interested, go to topenddevs.com/sign up, and you can get in right now for $39. When we're done, that price is going to go up to $75. And the $39 price gets you access to 2 calls per week. The full price at $150, which is going to be $75 over the next few weeks, that price is going to get you access to all of the calls and all of the tutorials and everything else that we put out from Top End Devs, along with member pricing for our remote conferences that are coming up next year. So go check it out, topenddevs.com/sign up. All right, Valentino, do you have some picks for us?
My pick is go see Takashi's great Ruby Kaigi talk. There's a hidden gem in there where he switches to Japanese without noticing. I thought that was great. Kudos to you for being able to think and speak in both languages. It was a great talk, so I recommend that seeing that. It was Ruby 4 and YJIT.
Awesome. I'm gonna throw out some picks. I don't have any board games to pick this time around. I'm gonna pick a board game convention instead. It's coming up in like 2 weeks. It's here in Utah. It's called TimpCon. The big one in the Salt Lake area is called SaltCon, but that one like sells out every year and it's hard to get into. TimpCon's in Utah County, and it's pretty awesome. I've wound up going for I went last year and I'm going this year doing the same thing. A friend of mine is part owner in a board game shop, and the board game shop does the game demos over in the corner for like 5 games. So we all learn how to play these 4 or 5 games, and then we teach them to people, right? So then you just walk up and sit down and we'll teach them how to play. The rest of the conference, you can either bring your own games or you can check out games from their game library, and then you play it with other people, right? And so you're just paying to be at the conference and, play with complete strangers, which is kind of fun in some ways. And you see some stuff you haven't seen before if you play with the same people on a regular basis like I do. So anyway, it's really fun. It's really cool to do it. And I recommend that people go find their own local board game conventions and find a way to connect with people. Besides that, I'm starting a book club for developers. And the first book we're going to do is Clean Architecture by Uncle Bob. And Bob has actually agreed to come to some of our book club meetings. So we're starting it in December, the first week in December, and we're just going to have a call every week and talk about the book. So if you want to come and talk about the book, then feel free. We're going to use some kind of conferencing software that allows you to have so many people kind of on stage, for lack of a better way of putting it, and then we'll just rotate people through. So if you have something to share, something to, some insight, some question, if Bob's around, or some question for the group, let's do it. And then what I'm really hoping to do is focus some of the discussion, because we'll have some discussion group too, like a forum or something around, okay, how does this apply to what the code I write, or, things like that. So looking forward to all of that. And that's going to be a ton of fun. Yeah, just excited about that. And then I did push back Rails Remote Conf to February. So if you were looking forward to that, that's going to be in February. And those are pretty much my picks. Takashi, do you have some picks?
I have a couple of picks. The first one is so-called Jiro ramen. So Japan have a lot of various types of ramens, and one of them is called Jiro ramen. It's because there's a ramen, like a franchise called Jiro, and it's kind of a sort of religiously famous or popular ramen franchise, and it's kind of harder to get that kind of Jiro ramen in the US, because it's I'm not sure if it's popular in the US, but recently in the Silicon Valley Bay Area, we got 2 places of Jiro ramen recently. So I was able to enjoy that at this place. So it's very good. Jiro ramen is basically a lot of garlic and a lot of meat. So and also in Japan, it's known for being very cheap. You only pay $5 to get a huge chunk of cabbage and sprouts and meat, and also a lot of garlic. And it's a strong taste, and a lot of people like that. But because you often end up being pretty fat by eating that, it's famous only for not fat people. That's not a good word to say, but yeah. So I like that. So it's good that I can eat that near here these days. Another pick is I speak I-bonds. So I-bonds is U.S. Treasury's provided bonds, and it's also inflation accelerated bonds. So it has now 9.62% interest rate guarantee, which is pretty good. Although it's gonna end this week, maybe listeners may not be able to buy that in the same rate, but still, this inflation is pretty insane. My rent cost is gonna increase 6% this year. It's unfortunate. I need to fight with that. So it's good that we have a 9.6% interest rate, and I bought that. Also, I set up a savings account that has a 3.11% APY, so it's good too. So I'm leveraging those kind of things to fight with inflation these days.
Very cool. Yeah, I have to say, I grew up just with the kind of the ramen packets you get at the grocery store here. And, so I was like, oh, ramen's just, cheap, kind of mediocre food. And then I went to a conference with some friends, and one of my friends had been a missionary in Japan. And so we went to Japantown in San Francisco and went to a ramen place. And I'm like, ramen place? Really? Yeah, yeah, right. And so we go eat there, and I'm like, this is the best thing ever. And come back and find out there are ramen places here in Utah. But it also turns out that my dad was a missionary in Japan, and he had that kind of ramen, and he had neglected to share it with me while I was growing up. And so he kind of caught a little bit of attitude from me for that, because I felt like I had been unfairly deprived as a child. We ate gyoza and fried rice and a whole bunch of other stuff, the way that he had it in Japan, the way he learned to make it, or, we'd buy it from the store. But yeah, never ramen. So anyway, I love that stuff. It's so good. So yeah. And what kind of ramen was it? Can you just type it into the chat so we can get it in the...
It's a Jiro. So it's a Jiro. It's a
Jiro ramen.
Very normal, common name of the Japanese first name. So yeah, that's why.
Cool. Yeah, I'll have to check it out. I think most of the ramen that I see around here is the tonkotsu,
I guess.
Yeah.
It's funny that there are
the pork.
So there's tonkatsu and tonkotsu. Tonkatsu is a cutlet of pork, and then tonkotsu is a soup made by pork. So many people got confused and say tonkatsu ramen, but it's basically wrong. And I see a lot of that here, so it's funny.
Nice. Well, I started learning Japanese, and then my daughter decided she wanted to learn Chinese. And so I'm learning Chinese with her. And when we're done with that, then I'll go back and learn Japanese because I think it's cool. But anyway, well, thanks for coming, Takashi. This was a lot of fun. And yeah, hopefully it helps people understand what's going on under the hood. And if you're dealing with things on the level of, hey, I want to optimize my VM or understand what's going on in there, yeah, there's plenty of stuff here to look at. So good deal. And then, of course, HAML. And HAML saves me headaches. So, all right, folks, we'll wrap it up. Till next time, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.